All right. Here are our connective tissue notes just in case you ever want to review them or you miss class. Hopefully this doesn't. Okay. So just as a review, tissues are as a definition, are closely related cells that perform related functions and are similar in structure. So we had four basic types that I told you guys we were going to cover. So we talked about epithelium already, which is all about covering. Today we're going to talk about connective tissue, which main function is to support. And then we will also finish this week talking about muscle tissue, which is for movement, and nervous tissue, which is for control. So, like I said, the function of connective tissue is supportive tissue that binds and hold the body structures together. So when we talk through a lot of the examples, you're going to see that most of them are involved in support, but then we have some other types that are involved in transport, exchange, and body defense. So you'll get to see what those examples look like as we talk through our connective tissue. One of the biggest characteristics of connective tissue is that it usually has a good blood supply, but there can be wide variations in blood supply when we look at some of our different characteristics. So some tissues are well vasculated. That means that they'll have a good amount of blood supply. Some will have poor, and some will even be completely avascular, meaning that they are going to have no blood supply. So the example that we're going to talk about that for is cartilage. The reason that this is important is because depending on one of the biggest things that changes depending on the blood supply is how quickly that tissue can heal if there's damage. So cartilage, for example, since it's avascular and it doesn't have a direct blood supply, and we'll talk when we get there about how it gets nutrients, because it still does, but since it doesn't have a direct blood supply, it takes a lot longer to heal. And so that's one of the consequences of variations in blood supply. If it's well vasculated, it is able to heal quickly. If it's not, if it's avascular, then it's going to take a lot longer to heal because it doesn't have the same flow of nutrients and support that an area that well vasculated is. So the other characteristic of connective tissue is that there's an extracellular matrix. And so this is the non-living substance produced solely by the connective tissue. And so it's going to have two main parts to it. It's going to have protein fibers, which these are fibers produced by specialized cells called fibroblasts that are within that connective tissue, and they secrete a protein that creates these fibers. And so depending on the tissue we look at, those fibers can be collagen, elastin, or reticular. And so collagen is going to be the most common one that we see through the different examples that we look at. The other thing that makes up the extracellular matrix is the ground substance. So this dictates how hard or soft the tissue is. It also has proteins, so the fibers and cells can be held together. There will be different chemicals in it depending on where it's located, and it also consists of water. So this is really where what dictates how hard or soft something is. So if it has a lot of water in it, it's going to be soft. If it has less water, then it's going to be hard. And you guys are going to see through our different examples of connective tissue that there really is quite a range of what these tissues look like within us. The extracellular matrix is important because it's used to absorb the pressure and weight. You will see that the fibers and the ground substance that make it up allow it to withstand stretching, abrasion, and shearing. It's also involved in protection. And like we said previously, the matrix can be really soft, as an example in fat tissue, because it's going to be mostly made of cells, but then it can be as hard as bone tissue, depending on the makeup of that extracellular matrix. So the type of connective tissue is dependent upon the makeup of the extracellular matrix. This is going to be one of the key components that we talk about. And so this is the review question that I did in class. What are the two main components of the extracellular matrix? So you got to remember it's the protein fibers, and those can be elastin, collagen, or reticulin. And then the other component is the ground substance. That's main component is water and some of those other proteins for adhering to the different structures in the cells that make up the connective tissue. So bone is the first type of connective tissue that we're going to talk about. This is the most dense. The reason that it's so dense, I believe it's on the next slide. Nope, I forgot. The reason that it's the most dense is because it contains all of these different mineral salts. And there's very few collagen fibers in the extracellular matrix. One of the things that I want to point out to you guys is this is the real life picture tissue sample of bone. This is an illustrated version of part of this picture. And so we're going to point out both because I expect you guys to know where both are, because we're going to spend a lot of time talking about bone the next unit as well. So one of the main components of bone is that it contains numerous Herversion systems. And so Herversion systems consist of a central canal through which the blood vessels and nerves pass. And then surrounding this canal are multiple concentric layers of bone. So what the heck that means is, let's look at the illustrated version first. So here's our nerve, vein, and artery. And so that's the Herversion system, or that's the central canal that we were talking about. What that looks like in our real life sample is these big dark spots. So those big dark spots are the central canal, and that's the nerve, artery, and vein. And so as you can see, we have a good blood supply in bone. And so since we have a good blood supply in bone, it actually heals very quickly, which I think sometimes is counterintuitive for students to think about. But bone actually does heal really quickly because it's vasculated, it has a good blood supply. And so then I think these kind of look like trees to me, but what we're seeing here is all of these little circles. Those are the concentric layers of bone that it's talking about. So what it's inside the bone, the actual cells are called osteocytes. Oops. So when you look down at your illustrated version, you can see the osteocytes kind of spread throughout those concentric circles around the central canal. And so they sit in this cavity called a lacunae and are surrounded by layers of that hard matrix that contains those mineral salts that make it hard. Sorry, guys. I think talking about bone is really fun because they have some crazy words. So there's the lacunae and then caniculus. And what's really cool is the caniculus are these lines that are stretched outward that allow the osteocytes, so remember those are the bone cells, to move materials between the different layers. So like I said, we're going to talk about bone a lot, but the biggest things that I want you guys to know right now is being able to identify that it's bone. The reason that it's hard is because of the mineral salts within it, and then that it heals quickly because it does have a good blood supply, and being able to identify that these dark rings, the dark circles in the middle, are the central vein, which carry the nerve, vein, and arteries. The next type of connective tissue that we're going to talk about is cartilage. And we're going to have 3 different types of cartilage that we're going to talk about. But first, we'll talk about some of the general characteristics. So cartilage is composed of cells known as chondrocytes. They actually only make up about 2 to 5% of the tissue's mass. There's a lot of extracellular matrix when it comes to cartilage. So the cells are located in a lacunae, which is similar to what we talked about for the bone. And then the cells within the lacunae are surrounded by that matrix. So like I said earlier, cartilage is avascular, and it must get its nutrients from nearby dense connective tissue known as the perichondrium through diffusion. So what the heck that is if we're looking at the hyaline cartilage that makes up the trachea. Hyaline is going to be one of the types of cartilage that we're going to talk about. But if you look up here, this is the perichondrium. So that's the dense connective tissue, and we'll talk about what that looks like later on, that actually is vasculated and has a blood supply that can supply these chondroblasts that are adjacent to it with the nutrients that it needs. But like I said before, because it doesn't have a direct blood supply and it relies on diffusion of nutrients from the perichondrium, cartilage takes a very, very long time to heal. So the other characteristic of cartilage is that nerves and nerve endings are not located within the cartilage. So, like I said, we're going to have 3 types of cartilages you guys are going to have to be able to identify and know some of the areas that they are located at. So, we'll talk about hyaline cartilage, fibro, and elastic. And so, hyaline cartilage is the most abundant. So, it has a lot of collagen fibers in its matrix, but it still has a pretty rubbery consistent. And so hyaline comes from a word for glassy. And when we get to look at long bones in the next couple weeks, you guys will get to see the hyaline cartilage, because hyaline cartilage is a very smooth, hard cartilage that is produced. And so it's really, what's nice about it being so smooth is that it cuts down on friction. So that's why we find it on the articulating points. So articulating means joining together to form joints. So we'll see it on the end of the femur where the hip joint is, and all of your joints. But that's the big one that we'll be able to look at in the next couple weeks. And you are going to be surprised at how smooth it is. But it makes sense. We want something that's constantly moving in another space together to be really smooth. And that's hyaline cartilage main function, is because it's pretty hard. It's got a little rubbery, so it's got a little give, but it's very smooth. So it cuts down on that friction in the joints. It is also found in the larynx. It's the cartilage that attaches the ribs to the sternum. So your sternum is that middle point in your chest. So if you've ever been a lifeguard or learned CPR, apparently they don't teach it anymore, but they used to teach us the sternum rub to check for consciousness, because it hurts really bad. So you just rub right in the hard part of the middle of the chest. Sorry, random story. But, and we will get to see this later on when we start talking about the bones that make up our thoracic cavity, but hyaline cartilage attaches our sternum to our ribs here in the center of our body. The other cool thing that I love is that when you were a little baby as a fetus, your skeleton actually started out as hyaline cartilage and is eventually replaced by bone. And so we will talk about this bone physiology and bone growth in our next unit. So you guys will get to know a little bit more about that change from hyaline cartilage to bone that takes place. The next type of cartilage is fibrocartilage. So this forms the disc between our vertebrae. It's found, and it's also found in certain bone joints on hips. Trying to think if there was anything else I wanted to tell you guys about fibro. Nope. And then the last one is elastic. So this is needed, it kind of goes with it. It's needed where elasticity is desired, like the earlobe or the end of the nose. So it's similar to hyaline, but it's made with the elastic fibers in its extracellular matrix instead of the collagen. So if I forgot to tell you guys that, the hyaline cartilage is made of collagen fibers in its extracellular matrix, where elastic is, surprise, surprise, elastic fibers. So this tends to be one of the areas that students struggle with the most in terms of being able to identify the different tissues, because they do look alike. And remember, I told you hyaline cartilage is actually what is white, blue, kind of glassy appearance. It is, but remember, we stain these slides so that they're visible. So it's not actually, they're not pink like this. So one of the things that I tell students is with the hyaline cartilage is that when we have samples of it, it does look very, very glassy. And we can see the space in between our cells is very smooth compared to our elastic cartilage, that remember is going to be more elastic, a little more bounce, not quite as hard as the hyaline cartilage. And we can tend to see more of those fibers within the extracellular matrix compared to the hyaline cartilage. And then fibrocartilage is unique on its own because the cells don't appear to be in as big of an area within the extracellular matrix. Oops, sorry. So that's the way that I tell those apart. If you have any great ideas, that you want to share with your classmates on how to tell them apart? I always look for new ones. You guys think about things in a different way than I do. So always be willing to share those. So now we're going to talk about dense connective tissue. So collagen fibers, and then the main component of its extracellular matrix, it forms strong rope-like structures, because this is where, when we talked about that connective tissue can have a lot of different functions. It can withstand stretching. Dense connective tissue is that example of being able to withstand too much stretching and provide support. So dense connective tissue is what forms our tendons and ligaments. So tendons are what attach skeletal muscles to bones. And then ligaments are what connect bone to bone in articulating areas. And so just remember, articulating means where two bones are contacting each other. And then one of the difference between ligaments and tendons is that ligaments contain more elastic fibers than tendons. Excuse me. The other place that you will find dense connective tissue is in the dermis, which is our lower layers of skin, where we want some more of that structure. Then sorry, I forgot to add a couple things for this. One of the other cool places that you guys will see dense connective tissue is in the white protective layer of the eyeball. And it's very strong. So like you guys can see, it's what makes up our tendons and ligaments. So it needs to be built to withstand pulling and provide the body, specifically our joints, to extra support while we move. Loose connective tissue. Sorry, I forgot to tell you guys. The way that I tell dense connective tissue is it looks like ropes. So you guys can see it down here. This is a picture of the dense connective tissue. It'll look like ropes. They'll be very organized. So that's the best way to tell if you're looking at dense connective tissue. And then we have loose connective tissue, and we're going to have three different types that we're going to talk about. It's usually softer because it has more cells and less fibers than dense connective tissue. So you won't see the same amount of fibers like we did in this one, right? So all of those there are the collagen. Hate that. The collagen fibers. The collagen fibers that are in the extracellular matrix of our dense connective tissue, whereas our loose connective doesn't have those same amount of fibers. And so the loose connective tissue also contains chemicals within our ground substance to attract water to create variations in viscosity. So viscosity means how liquid or solid it is. So it can almost be gel-like sometimes. And so we're going to talk about the three different types that you guys are going to be able to identify. So like I said, the more water that's in the ground substance, the more fluid-like it is going to be. So that's one of the defining characteristics of loose connective tissue, is that it's going to be more fluid-like than some of the ones that we previously looked at. So the first type of areolar or loose connective tissue is areolar. It's characterized by 7 types of cells. It has loose arrangement of fibers, and it's very fluid-like. So it is underlying the connective tissue for most epithelia. So remember, we talked about the fact that epithelial cells do not have a direct blood supply. So it's the loose connective tissue, the areolar, that's underneath that has the blood supply so that it can provide nutrients to the epithelia that lie above it. So like if we start thinking about the layers of tissue, we're going to have epithelial tissue on top, and then connective tissue usually lies underneath of it, just so that you guys can see the connection between those different tissues, because remember, they're all working together. The other function of the areolar is it forms the mesentery. So the mesentery is this tissue that supports our organs within our abdominal cavity. So it has the blood vessels and nerves, and it's in all of the nooks and crannies of most tissues. And so the mesentery is what keeps all of your organs in place. So when we get to do cat dissections and you guys start to look at the abdominal cavity, the mesentery is all of this tissue that's in between the organs and holds all those organs in place. So like when we pull out the intestines, you're going to see all this tissue in between it, and that's the areolar loose connective tissue that we'll be able to talk about again. That's one of my favorite things about this class is it's not one little thing that you guys can learn about and forget, because we're going to continue to use all of this information as we move through the year. So our next type of loose connective tissue is adipose. So this is fat tissue. So this is a tissue in which fat cells predominate. The cells and tissue store oil. So everyone thinks fat is bad, but your body needs fat. Your brain is mostly made of fat. And fat is a great fuel source when you have used all of the carbohydrates that are, in the reserves. And so it can be used as a source for energy when we need it. And it also forms the subcutaneous layer of skin and insulates our body. So it's really important that we have fat. And so let me make sure. It protects the organs, surrounds them, cushions the eyeball and the socket. It's found in storage in breasts and hips of women and in the midsection of men. So that's sometimes why, especially as we get older, why men and women sometimes carry weight in different areas. And that's due to where more of these adipose cells are located. And so when we look at our picture, what you're looking at here is some of that oil, the lipid droplet that we talked about. Then the in-between space is the extracellular matrix. And so we can see that it looks very different from the other ones that we looked at. And then here's the nucleus of one of the cells. So what is interesting is that if the body needs to start using this fat as a fuel source for energy, that oil is going to go away. And then all of these cells just start to look like fibroblasts. So it looks very different compared to if it's storing oil or if it's not. But your guys' pictures will always be as if with it being oil stored in there. So they'll always look like these big kind of round bubbles. And just know that the darker spots are the nuclei of the cells. And our last type of loose connective tissue is blood. So it's considered connective because it consists of blood cells surrounded by a fluid matrix, which is the plasma. And so these protein fibers of the matrix only become visible during blood clotting, right? So it's usually very fluid-like. But then if we need our blood to clot, that's when we see all of those protein fibers start to work together so that we don't bleed out. We will get to blood more at a later time as well. And for some reason, my students always confuse adipose samples with blood samples. So I just want to be clear. These are the cells. When you see these big clear bubbles, that's the fat oil that's being stored. Whereas with blood samples, we don't see that connectiveness like we see in the adipose. So it's just, these are the red blood cells. They're nice and round most of the time, unless they're sickle cell anemia. And then they look like crescent moons. But for all of the samples you guys are going to look at, the blood samples will be these nice round spheres, since you guys will have to be able to do that on your quiz. So just a couple of review questions that I had at the end of class. So what type of connective tissue is primarily used for fat storage? Adipose. And then that was a multiple choice. You guys can't see it, but it's what is not a characteristic of connective tissue. And I wonder if I can, here we'll X out of it so that I can look at what the heck the choices were and tell you guys what the answer is. Maybe. Where's my teacher notes? There they are. So the options were connective tissue usually has a good blood supply, which it does most of the time unless it's cartilage. So that is true. B's choice was connective tissue is defined by the presence of an extracellular matrix, which it is, right? Because that extracellular matrix can contain different fibers and a different ground substance, which determines what it looks like, which determines its function, right? So blood, we need it to flow and move a lot. And so it has a lot of fluid in the ground substance. So think about examples like that. C, the extracellular matrix of connective tissue may be solid, semi-solid, or liquid, which is true. And then D, the last one, the cells of the connective tissue are closely packed together. That is the one that is not a characteristic of connective tissue, because what we can actually see through our slides is these cells can be very spread out throughout the extracellular matrix. Like a great example of that is our cartilage. If we go back up to this labeled picture, because here are the chondroblasts spread throughout the extracellular matrix. And so they're not tightly packed together. The tissue that does have its cells tightly packed together are epithelial. So just remember, tightly packed cells is a characteristic of epithelial, not connective, because they're going to be spread throughout the extracellular matrix. So hopefully this helps you guys. If you need to rewatch it or do anything like that, let me know if you guys have any questions. Remember, the biggest things that you guys need to be able to do with connective tissue is identify and know how the extracellular matrix affects the structure, which then thereby affects the function and where it is located. So if you guys have questions, please let me know. Ah.